Welcome to a new lesson. Today we are going to learn more about the summer season and make some revisions too, especially about the house behaviors. We we have been learning about more about in the winter. In the summer, normally there are some differences. In terms of calculations, it's not that hard. Sometimes because there's not much to do about it. And in another way, it's somehow easier to control the worm because people don't die. Simply that, like that. We don't we don't come so much sick in the summer as we do it in the winter. Therefore, there's another kind of preoccupations. Of course, there's another diseases with the summertime, but inside the house, it's not necessary the major problem as we have. So the control that we can achieve in bioclimatic actions in most ways, it's enough while we're doing to winter. It applies in a certain way. Of course, there's differences because you can't expect to make everything good to winter to benefit the summer. That's not true. If we remember what I've told, we need to gather a balance, which means, for example, if we use too much glass windows in this case, in the summer it will be unbearable. And that's not what we want. We actually want to earn energy for the winter, but we also want to close it for the summer. Because we nobody wants in warm places, nobody wants more heat than we already have, and the windows sometimes can be really annoying for that. So that way, let me start the slides. And so we are going to make some revisions, and we are going to talk about summer, in which here implies the cooling season. So, as a house behavior recap, the U value now includes everything, which also it is ventilation, people environment, and the kind of equipment. And for our heating season, this is winter, we have the cooling season that we are going to talk about it today. Remember that equipments have intermediate intercalary powers. They are not always continuous, except for certain, like a refrigerator. It has a continuous energy, and it's more easy to measure by the power it has. But we can know a little bit how much actually equipments are expending in the whole energy of the house. It's just consider all the equipments we have there. Now, also, the difference between summer and winter starts like this. While in the winter we try to earn it to the inside, in the summer the big difference with winter is we try to avoid it. It's too much, and we need to remove it, not earn. So for summer calculations, We still have the inside earnings like people and equipment, but we also add the U value, the outside earnings. This time we don't calculate it with TLBs. We don't apply them. And we also subtract the ventilation because ventilation is always to lose. So it's a must. It's a good thing for the summer. Remember again, ventilation, too much ventilation in the winter always is bad. In the case of the summer, it's actually good. Okay? But now it is supposed to avoid energy inside the house. So, because it's summer, and the idea is to avoid energy inside the house, completely opposite of the summer season. We earn too much energy, we don't want that energy, we want to remove as fast as it's possible. Now, about the calculations, let's first understand the inside earnings. About this, we have people and equipment, and we have our area, and we have our summertime hours, which is our number here that we need to know. And our equation is all of that divided by 100. So let's work this out. We have 4 people in some equipments, which basically we can consider that it's one equipment or several equipments at 100 watts total, plus actually 300 watts. The 01 is the number of watts per hour that we are going to have, which in this case we are going to have 700 watts per hour in our case. We have an area, a floor plan says it's 90 square meters, and we get the number of hours in the whole. The summertime is 2,928 hours. We know how this is calculated is very straightforward. So we are talking about, imagine 4 months of summer, and that's 122 days, and 122 days per 24 hours, we get 2,928 hours totally. So it's 0.7 multiplying by the area of 90 square meters, multiplying by 2,928 divided by 100. All of that divided by 100. That is 1,844 kilowatts a year. So in a whole, we will get 1844 kilowatts in a year. Assuming that people are 24 hours a day, one person is 100 watts, we still remember that. If people were at home only 10 hours, 0.045, equipments are 24 watts, like thermo heater, fridge, all kinds of gear inside the house permanently. One thing very important, the air condition that we normally hear is also called a heat pump. And we have also a boiler for water, but it's not electric. And we have the U value, outside earnings without TLB, plus the ventilation. These are the data that we have currently for this kind of exercise. So, if we continue, The U value outside earnings, except thermal linear bridges, radiation intensity earning by the sun depends on the exposition, geography, and society culture. We'll consider 500 kilowatts a year for south and apply index of 0, and north 0.5, and east and west 0.95. This means simply because the index of orientation is different for the areas. Let me explain this in a whiteboard. We are talking now about the implications of the sun. So we have our house here, and the sun makes this rotation, especially in the summer, it goes longer. So imagine that this is our line. Um, and this is here, this is east, in this case northeast, and here is about the northwest. Okay, we are at the peak of June 21. So this will be south. Here it will be east. Here it will be west. So the incision of energy here has a value of 1, but here there's no light. North doesn't get it, and here will be 50% as well as here. So here probably less, we can say that will be like 75, and here 25. Oh, I did exactly the opposite, sorry. Here is 75, here is also 75. Here we need to delete, and to get this well, this is 25% here and 25. Yes, so daily, this is daily rotation of the sun, 20th June. So the energy that comes from here and this. So this energy this is a second. This rays basically is the intensity of the sun rays. In this case, south will be 100% of 2000, and um, 2049.5 1844. No, directly here to 18 1844. But if it's in east, it's 50% of 1844. Okay, so this is not very difficult to understand. Basically, it's very straightforward. So let's come back here to the board again and check the rest that we were talking about. We are here now. So let's try to understand now by the windows. We know that the earning that we give from the windows are different by the position. Therefore, we need to calculate them. And we see, well, there's 7.5 square meters that it is for the whole, which basically, if they are all for self, it's 1237.5. Now, imagine now, you have 500 for self, 0.43, and the constant. For north, the factor is 0, so it's nothing. And for the east, it will be 0.5 because it's for east in case of having 20 square meters. This is for in case of the walls. So this is the earnings. We have to discount the windows, in this case, don't forget it. And after the rest of the envelope, pavement and roofs don't have index of orientation. In the case of the ventilation, again, we have the volume, we have the 0.5 RPH and the summers. Summer months are 4, we have seen that, 0.5 with the volume, which is the 90 square meters with something on the height, it's equal to 500K. So at the end, what do we have? We have the windows, walls, pavement, roofs, ventilation. Ventilation is a subtraction. 1247 plus 63 plus 0 if middle apartment minus 500 from the ventilation, we get 801.02. Plus inside earnings is 1844, which means that, remember, the people and so on and so on. So it means that at the end we have 2645.02. It is not very hard. It is a simplified equation. The idea, again, is the same. You just need to know how does it process, and once you know, it is easy to comply. It's not very difficult at all, and that's the only thing about summer. That's why we can learn it in 20 minutes, basically. Okay, and that's let me stop share. That's it about the summer. I hope you have enjoyed everything. And now you know basically how to calculate the whole losses of the house during the whole year. Okay? Thank you very much and see you in the next class.